So now this is the third and last part of my lecture about the load flow studies. So in our syllabus, there are two load flow studies we have to cover. So first of one, Gauss-Seidel method, which I've already discussed, and the second and last one is the NewtonRaphson method. So there are several disadvantages of Gauss-Seidel method. That is, if the power system is considerably large, then by using the Gauss-Seidel method, it takes several number of iteration to solve the load flow study problem. So if the bus is considerably very large, like 150 or 250 bus problem, then the Gauss-Seidel method may be it can be failed, or it may be failed to find out the desired solution, or it takes a little bit more time to find out the solution, because the equation of Gauss-Seidel method is very easy, but the convergence time or the convergence rate by using the Gauss-Seidel method is very poor actually. So here the advantage of NewtonRaphson method, because the convergence rate of this NewtonRaphson method is very high. So like 3 or 4 or 5 times of iteration, or 3, 4 or up to 4 or 5 uh, number of iteration, we can find out our desired solution for any load flow study problem. So this is the highly convergence rate method. This is the NewtonRaphson method, and this is an efficient method to solve the load flow studies. But the problem is the equation of this method is a little bit complex, and it needs to uh, a large portion of memory of computer. So now we need to discuss about the NewtonRaphson method. This is another solution process. By using this method, we can solve the load flow problem. So we need to discuss the NewtonRaphson method. So this is the NewtonRaphson method uh, equation actually. This is a real power equation, and this is the reactive power equation, P and Q. Now if we expand this equation, real or reactive power equation, in Taylor series formula, and by neglecting the higher order, we can find out this type of complex equation actually. So this is the complex equation, but how we can formulate this equation, this is not, we don't need to know actually, that is how we can formulate this equation, but we need to know the application of this equation actually, and which term, what is the meaning of this equation actually. We need to understand this equation to solve the load flow problem by using the NewtonRaphson method. So this is the equation, and this is the final equation of NewtonRaphson method. So the left portion of the equation, that is this portion, that is P and Q, this is the matrix, and this matrix is known as the power mismatch matrix, because in this matrix only power is placed here, nothing else. So this matrix is known as power mismatch matrix. And now the very most right side of the equation, this matrix is known as the correction matrix. It means that the values we need to determine are put here, because we know by using the NewtonRaphson method, we need to determine the voltage angle and magnitude. We need to determine the voltage angle and magnitude. So this delta is represent the voltage angle, and this mod of V is represent the voltage magnitude. So these matrix is consider the values which we need to determine. So that's why this matrix known as correction matrix or correction vector. And the very left side of the equation, this matrix known as power mismatch matrix. And the middle portion of our equation, these a huge matrix, and this matrix is known as the Jacobian matrix. Actually, this is the Jacobian matrix, and the formulation of this matrix is the most easiest part of our method. So this is the most easiest part of the method. So now at first we have to discuss about the power mismatch matrix. We need to discuss about the power mismatch matrix. Now, so this is the power mismatch matrix. So the order of this matrix is at first the real power. After this, there will be the reactive power. So this is the order of this matrix. At first the real, and next one the reactive power. And this is the correction matrix. So the formation of the correction matrix is at first the voltage angle, and next the voltage magnitude. And this is the Jacobian. And the formation of Jacobian matrix is we have to partial derivative this power equation by the correction matrix. So this is the formation of Jacobian. So this is the general formation of this. Actually, this is the general formation of the equation of load flow studies by using the NewtonRaphson method. So by using the NewtonRaphson method, this is the general equation. So this is the power mismatch matrix, and this is the correction matrix, and this is the Jacobian. So now, for an example, if we consider there are 3-bus power system, if we consider there will be 3-bus power system, in which bus 1 is a slack bus. So slack bus is bus 1. And next the PV or generator bus, that is bus 2, and the PQ or load bus, that is bus number 3. So if we consider this is the power system, that is the total number of bus 3, slack bus is bus number 1. So well, this is the slack bus, that is the bus number 1. Bus number 2 is the PV bus number 3 is the PQ bus. So then whenever we find out or we have to write down this power mismatch matrix, here there should be delta P, that is the real power at first. So bus 1 is a slack bus, we don't need to find out anything for bus 1. So bus 2 is the PV bus. Now for PV bus, P2, that is the real power is given, P2 is given. So that's why we can calculate the power mismatch of bus 2, real power mismatch, because P2 is given. And we know the power mismatch equation is scheduled power minus calculated power. So we have to calculate the power of a particular bus, and we have a given power, that is the schedule value. We have to know this schedule value, and this value should be given in the question. So if this is a PV bus, then only the schedule power value or the real power value will be given in your question. So if this is a PV bus, then P2 we know. So if we just subtract the schedule value of P2 minus the calculated value of P2, we will get the power mismatch, that is the del P2. So this is the del P2. So this is the first element actually of this matrix. This is the first element. Now the second element, that is for bus 3, this is the PQ bus. So bus 3 real power is also given because this is the PQ bus. So P3 is given in our question. So if this is the P3 is given in our question, then we can again calculate the real power mismatch for bus 3. So the second term or the second part of this power mismatch matrix should be delta P3. And now finally, the third term for this particular power system, that is all the real power mismatch are placed here. Now PV bus, so there will be no reactive power is given, so we can't calculate the reactive power mismatch. and here this is a PQ bus. So reactive power is given here Q3. So we can calculate the reactive power mismatch. So that's why the third part of this particular matrix is delta Q3. So this is the three element of this particular power mismatch matrix, that is delta P2, delta P3 and delta Q3. So this is the power mismatch matrix, or how we can formulate this power mismatch matrix. And this delta P2 means what? This delta P2 means P2 schedule minus P2 calculate value. So this is the equation, P2 schedule minus P2 calculate value. So this is the delta P2 means this. So delta P2 means we have to subtract the calculated power of bus 2 from the scheduled power of bus 2. Then we can find out the power mismatch matrix element. And similar for P3 also, because this is P3 schedule and this is P3 calculate. And if it is for Q3, then there should be Q3 schedule value minus Q3 calculated value. So these three is the element of power mismatch matrix. Now for the correction matrix. So this is, we can write down this. This is the elements of, that is power mismatch. So this is the elements of power mismatch matrix. Now this is the correction vector. So what is the element of this correction? So what is the element of this correction matrix actually? So element of power mismatch matrix, now the element of correction matrix. So again, in our particular power system, the total number of bus is 3. Bus 1 is slack, bus 2 is PV, and bus 3, that is PQ bus. That is bus number 3 is the PQ bus. So now we have to find out the elements of power mismatch matrix. So the order of this element is, at first we have to put down the voltage angle, and next we have to put down the voltage magnitude. So this is the order. So now for bus 2, voltage magnitude is given. So we have to determine the angle. So the element is the angle of V2. So we need to find out the angle of V2. We need to find out this. This is the first element. The second element is, for bus 3, we don't know the voltage magnitude and angle. So we have to determine the voltage magnitude and angle. Also, we have to determine these both two values. But the order is, at first we have to put down the angle value, next magnitude. So for the second element, that should be the angle of V3, the angle of V3. And finally, the third element is, that is the PQ. So we don't know the magnitude of bus 3 was bus voltage. So that's why we have to calculate the magnitude of bus voltage of bus 3. So here, this is the magnitude. So I can put down this here. So here, this is the magnitude of V3. So we have to find out the magnitude of V3. So here, if this is for a particular power system, by using the NewtonRaphson method, these are the elements for correction vector. So how we can find out or formulate this element of correction matrix, and here I have discussed how we can formulate the equation of power mismatch matrix. Now this is the Jacobian. So how we can calculate the Jacobian matrix? So J1, J2, J3 and J4. So the Jacobian we can calculate here. This is the partial derivative of this power equation. So at first the power equation is del P2. So we have to partial derivative this del P2 by, at first this is a 3-1 matrix, and this also correction vector is also 3/1 matrix. So this Jacobian should be 3/3 matrix. So 3 rows and 3 columns. So at first here this is the P2, del P2. So del P2 we have to derive this del P2 partially derivative by, the first element is angle of V2. So delta 2. Next, the second term should be del P2, and we have to partial derivative it by del 3, that is the angle of V3. And finally, del P2, that should be partial derivative by the magnitude of V3, that is mod of V3. So this is the first row, is for how we can formulate the first row of Jacobian matrix. And second row and third row as goes on. So now if we again just come back from our PDF lecture. So by using the NewtonRaphson method, this is the equation of NewtonRaphson method. And now how, if we consider, that is if we consider 3-bus power system where bus 1 is a slack bus, bus 2 is a PQ bus, and bus 3 is a PV bus, then how we can solve this particular problem by using the NewtonRaphson method. So now we, for this particular problem, at first we have to identify the equation by using the NewtonRaphson method. So this is 3-bus power system. So there should be 3-1 row of power mismatch matrix. So here for bus 1 is so actually it's P1, it doesn't matter, because if bus 2 is also a PQ bus, bus 3 is also a PQ bus, then there should be a 4 power mismatch. So now, so here bus 2 is a PQ bus and bus 3 is a PV bus. So for bus 2, PQ, so P2 is given. So that's why we can calculate the real power mismatch del P2. Next, del P3, because bus 3 is the PQ bus, PV bus, and bus 2 is the PQ bus, so del Q2, reactive power mismatch of bus 2. And for correction vector, bus 2 is a PQ bus, so that's why del 2 we don't know the angle of bus voltage V2, so that's why delta 2. Next, delta 3. Next, del V2, because bus 2 is the PV bus. So if this is a, so again I just means bus 2 is a PQ bus. So if bus 2 is a PQ bus for this particular problem, then we don't know the angle, voltage angle of bus 2, and we don't know the magnitude of bus 2, because this is a PQ bus. So that's why del delta 2, the angle of bus 2, and this is the del V2, this is the magnitude, and the order should be angle then bus voltage, and this is the Jacobian. So how we can formulate this Jacobian? This is the P2. So this row is for P2, that is this P2, P2 and P2. So at first, the first element P2 should be partially derivative by del 2. So del, this is the partial derivative sign or partial derivative function, and then del P2, that should be second term, and that should be derivative by del 3, and the final or third term, that's del P2, should be derivative by del V2, that is the voltage magnitude. This is the second row of this Jacobian, and this row for power P3. So first element P3 should be partially derivative by del 2, then P3 should be derivative by del 3, and P3 should be V2. And finally, this is the row for reactive power Q2. So Q2 partially derivative by del 2, and Q2 by del 3, and Q2 by V2. So this is the formation of Jacobian, or how we can formulate the Jacobian by using the NewtonRaphson method. So now we have to determine the power mismatch for P2 or bus 2. So what is the equation of P2 actually? So this is the real power equation. P2. And this equation here, we write down this equation for this particular power system. Here there are 3 buses, so this equation contains 3 terms. So that is the real power equation for bus 2. It means that voltage V2 conjugate into current I2. So there are 3 buses, so this current should be 3 parts, 1, 2, 3. And here this is the angle, all are the angular cosine because this is the real power equation. And this minus sign is for conjugate, that is the V2 conjugate, that is del 2. And here this is the equation for P3. Now we have to put down the values here. Whenever we put down the values, we will get the calculated power value P2 and P3. And whenever we subtract this value from the given power value, then we can find out the del P2, del P3. This is the power mismatch value, and similar for the reactive power Q2. So this is the process how we can find out this power mismatch matrix value. Next, this is the correction matrix. So we don't know the value. We have to calculate, or we have to find out these values. So next we have to find out this Jacobian matrix. So at first we have to partial derivative these equations to find out the equation of this Jacobian matrix. We have to partial derivative. So this is the P2 equation. Now we have to partial derivative this equation by del 2. So if we partially derivative this P2 by del 2, then here del 2 is present. So whenever we partial derivative this equation, cos should be sine, and this minus should be in front of this. And if cos should once again convert to sine, there should be again one minus. So minus minus will be plus. So if we partial derivative this equation by del 2, the first term should be V2 into V1 into Y21 sine of theta 21 plus del 1 minus del 2. Now the second part, there is no del 2, so this should be 0. This part should be 0 because the derivation of constant would be 0. So this should be 0. And the third part, again there will be a del 2. So this minus, and cos is converted to sine. So this minus should be plus. So second part will be V2, V3, Y23 sine of theta 23 plus del 3 minus del 2. So if we partial derivative this equation, that is P2 by del 2, this equation should be look like this. So at first we have to find out the partial derivative equation actually, or we have to find out the Jacobian equation at first. So there are 9 elements of this Jacobian. So we have to find out these 9 equations. So if I just show another equation, that is the del P3 and the partial derivative of this P3 by del V2. Then this is the equation of P3. If we partial derivative this by V2, then here there is only one V2 is present here. So this first term should be 0 and third term should be again 0. And the second term V3 Y23 cos of theta 32 minus del 2 plus theta del 2 minus del 3 plus del 2. So this is the equation. Formulate. This is the partial derivative equation. So after we find this 9 partial derivative equation, our next process is to put down the values in these separately 9 equations and find out the algebraic value or the numerical value for this Jacobian. So whenever we find out 9 numeric value, then we find out the Jacobian. So now we have to determine the correction matrix. So the correction matrix should be the left portion of the equation and all other should be the right side. So if we just want to change the Jacobian matrix position from right to left, that should be inverse matrix. So we have to inverse this Jacobian matrix, and then we have to multiply this with the power mismatch matrix. Then we will find out the correction vector or correction matrix. So our next process should be, we have to inverse the Jacobian and we have to multiply this matrix with the power mismatch matrix. Then we will find out the correction vector or correction matrix. So this is the correction matrix determination process. Whenever we find out the correction matrix, our next process is to update the value. So the assumption value, that is 0 degree for del 2. Now we have to add our correction matrix value del 2. That is the process how we can update it our values. So this is the first time iteration value, and this goes on. This is the del 3 first time interaction value. That is the assumption value plus the correction value. Similarly, for the voltage magnitude, the assumption value plus the correction value. Then we can upgrade the values. Now we finally upgrade the values, but we don't know these values is correct or not. We don't know these values is correct or not. So again, we need to recheck our value. So we have to check our values by using the tolerance level. So which is the tolerance level? If we just this is the tolerance level. So whenever we find out the upgrade value, then we have to check this value as our tolerance level. So how we can check the tolerance level? Once again, we have to calculate the power mismatch. By using this update value, we have to calculate the power mismatch matrix. So if the power mismatch matrix satisfies the tolerance level, then the result we have just calculated, this is the final result or final solution. And if this power mismatch matrix doesn't satisfy the tolerance level, then the values we have calculated, this is not our desired solution. So once again, we need to calculate the Jacobian, and we have to determine our new correction matrix. We have to update this value. Next, we have to check the power mismatch matrix by using the update value, and after that, finally, we have to consider the tolerance level. If the tolerance level is being satisfied, then the last result of correction matrix is our solution. And if not, this process is going on. So this is a complex process, and it takes a large number of computer memory, but this is a high convergence rate method. So around 3, 4, or 5 iteration, we can find out our desired solution. So this is the all about the NewtonRaphson method. This is all about NewtonRaphson method. So this is the Nagrat Kothari book, power system element on power system analysis, and this is the chapter 6, that is the load flow studies, and this is the NewtonRaphson method actually. So this is the 6.6 NewtonRaphson or NR method. So this is the NewtonRaphson method equation, and finally we need, this is the mathematical problem actually, example 6.6. So this is a particular power system diagram, online diagram, 3-bus power system diagram, and for this 3-bus power system diagram, the reactance value is given, that is the each of 3 lines has a series impedance of 0.02 plus j 0.08. So this is the series impedance value is given, and the shunt admittance is j 0.02. So shunt admittance is given here. So shunt admittance means the susceptance is connected from bus to the neutral. So shunt admittance means susceptance connected from bus to neutral. So we have to consider this admittance value whenever we calculate the self admittance, that is the y11, y22, and y33. We have to add this shunt admittance value directly with the self admittance. So after considering this, we can find out this 3 by 3 bus admittance matrix. We can find out this 3 by 3 bus admittance matrix. This is the Y bus matrix. This is the first solution process, that we have to identify the bus admittance matrix. Next, our question is for bus 1, bus 2, and bus 3. This is the slack bus, bus 1, bus 2 is the PQ bus, and bus 3 is the PV bus. So the bus voltage magnitude is given for bus 3. Now we have to find out the solution or load flow solution by using the NewtonRaphson method, and the tolerance level is also given here, 0.01. This is the power mismatch tolerance level. This tolerance level for power mismatch. So now whenever we find out the Y bus matrix or bus admittance matrix, next we have to determine the real and reactive power to find out the power mismatch. So here P2 is given in the question because this is the PQ bus. P3 is given in the question because this is the P3 bus, and Q2 is given because bus 2 is the PQ bus. So P2, P3 and Q2, these three power mismatches we have to calculate. So this is the equation of P2, this is the equation of P3, and this is for Q2. So if we put down the values here, then we can find out this the power mismatch. This is the power calculated power value, and if we subtract this calculated power from the specified or given power, we can find out the power mismatch value. And now these values we have to put down here because this is the power mismatch matrix. Next, this is the correction matrix, and the middle portion, this is the Jacobian matrix. So we have to calculate the Jacobian matrix at first. So to find out the Jacobian matrix, we need to find out the 9 partial derivative equation or 9 Jacobian matrix element equation. So after that, we have to put down the values there, and finally we can find this 3 by 3 Jacobian matrix. That is the numerical value. Now we need to inverse this matrix. So this is, we have to inverse this matrix, and this is the power mismatch matrix. This is the correction matrix. So we need to inverse this matrix, and we have to multiply this with the power mismatch matrix. Then the result should be, this is the correction vector, or this is the correction matrix or correction vector. So we need to update this value. So we have to add this value with the assumption value. So this is the upgradation of the values. So after that, we have to check our tolerance level. So to check our tolerance level by using this upgrade value, once again we have to calculate the power mismatch. So we have to calculate the calculated power, then we have to check down the power mismatch matrix. So if power mismatch matrix is satisfying the tolerance level, then this is our solution. This is our solution. And if these values are not satisfying the power mismatch matrix or tolerance level, not satisfying the tolerance level, once again we have to calculate the Jacobian. Once again we have to inverse this Jacobian, and we have to multiply with the power mismatch matrix, and finally once again we can find out a correction matrix. And after that we have to check our tolerance level. So if we solve this problem by using a computer, then after 3 iteration we will find out our desired result. So this method or this particular problem need to 3 NewtonRaphson interaction to find out the solution. So in your question actually you have to calculate this by using your hand. So by using your calculator, so the length of your mathematical problem is such that you can solve the problem by using your time limit. So the solution length will be look like this. So this is all about our load flow study. Once again, I have to forget to say one thing or to tell one thing, that is in Nagrat Kothari book, if we just pass several pages, then the 6.8, this is the comparison of load flow methods. We have to read this paragraph actually. We have to read this paragraph. Here there are comparison is here for several types of load flow problem like Gauss-Seidel method, NewtonRaphson method, fast decouple method. But in our syllabus, we just know about 2 load flow studies method. One is Gauss-Seidel and another one is NewtonRaphson method. So from this particular article, we need to read the comparison between the Gauss-Seidel method and NewtonRaphson method. So this is the last thing I have to say, and this is all about our load flow studies chapter. So we have discussed the Gauss-Seidel method and NewtonRaphson method, and this is all about the load flow study chapter. Thanks to all.